Good morning, boys and girls, and welcome back. Today we're moving on to the next section in this unit, where we're going to talk about multiplying monomials and dealing with exponents. All right, so kind of quick little review here with powers, with both vocabulary and how we deal with them. Like we talked about in the first unit, this thing on the bottom here, that 3 is called a base. Okay, for number 1, the 3 is called the base. The 4 is an exponent, or power. Okay. And then if you have a number in front, that is a coefficient. So I'm trying to glance down here. Maybe it's some of the ones below. I don't think. But down below, if I had a number in front of that, here we have x is the base, 3 is the power exponent. If I had a number in front of that, that would be the coefficient. Okay. What the power or the exponent tells us is how many times to multiply the base. So 3 to the 4th again means 3 times 3 times 3 times 3 means I want to multiply that out 4 times. Okay? And then you're just going to multiply these together. You can do 3 times 3 is 9, times 3 is 27, times 3 is 81. Or you could just go, hey, 3 times 3 is 9, times 3 times 3 is 9, and 9 times 9 is 81. But you should be able to evaluate that power. I guess we could always just put in our calculator too. 3 to the 4th is 81. All right? So 1/2 to the 3rd power is 1/2 times 1/2 times 1/2. I got to do it 3 times. 1/2 is the base because it's all inside parentheses. When you multiply fractions, you multiply across the top. So 1 times 1 times 1 is 1. And 2 times 2 times 2 is 8. So in this case, we get 1/8. All right. -2 to the 4th power. So same idea here. When I have that -2 inside parentheses, then that -2 is my base. So this is -2 times -2 times -2. I need another one in there times -2, running out of space. Okay, so -2 times -2 times -2 times -2 is the same as 4 times 4, or we get 16. All right. -5 to the 3rd. In this case, we have, -5 times -5 times -5. And so a negative times a negative is a positive 25 times -5 is -125. All right. Just a few things why we have examples 3 and 4 here. When you take a negative number and raise it to an even power, notice that these things will always match up nicely. All right. And so you will always end up with a positive answer. That's a rule that you can kind of make. When you have an odd number, now these two match up nicely and they gave us 25, but then I had the extra negative on the end, and so when you raise a negative number to an odd power, you will always end up with a negative answer. Okay? With that being said, number 5 we got to watch out for, because number 5 is not -6 squared like number 3 is -2 squared. Number 5, that squared is only on the base of 6. That negative in this case is not inside the parentheses, so it's technically not part of the base. It is technically a coefficient. So what we really are saying with this is negative, and I'm just squaring the 6. So it's -6 times 6, or we get -36. Where you really got to be careful with this is when we use the calculator. If you want to square -6 and you just put -6 squared and it looks like that, it's going to give you the wrong answer. If you want to square a negative number, you have to put it in parentheses. Okay? Okay, I just want to show you real quick. See, on the calculator, it knows the difference between you put it in parentheses or not. So be very careful. Watch out for this. It's one we frequently mess up on, so pay attention. All right, next we come to our product of powers property, which says if you have a base and an exponent and you multiply by another same base with a different exponent, a to the m times a to the n, what you can do then is you can go ahead and you can add those exponents. And your new answer would be a to the m plus n. The base is always going to stay the same, and I'm just going to go and add exponents. So for like on number 6 here, x to the 3rd times x to the 5th, my base stays the same, and I'm just going to go and add exponents. And this becomes x to the 8th. If I was unsure, I could write that out as x times x times x, times x times x times x times x, and I'll see that I'd get x to the 8th when I wrote it out long ways. Okay? When in doubt, write it out is a good saying that you can kind of use. All right? 7y times y to the 4th. Here, that's really y to the 1st. If there's no exponent, remember there's always an exponent of 1. So this becomes 1 plus 4. This is a good way for you to show your work so we know what you're doing. That way, if you added wrong, we knew you still at least knew the proper way. I always tell my kids, if you don't have any work, I can't see what you're doing in your head, and I'm going to have to take away full points. But if you do little things like that, and you're showing me that you're adding them together, then I can try to give you partial credit even if you mess up. All right? Watch out on number 4 here. 4 to the 3rd times 4 squared. 4, again, in this case, is a base. It is not a coefficient. So the base is going to stay the same. I'm going to add exponents, and so we end up with 4 to the 5th. Okay? On number 9, x to the 3rd times y to the 4th. My bases aren't the same here, so I cannot go and add exponents. I can't put those together. I mean, I kind of put them together as far as, like, I get rid of that multiplying sign, and I just put them right next to each other, which implies multiplication. But this would just be written as x to the 3rd, y to the 4th. All right. As we start getting a little more advanced here. Okay. A to the 3rd, b squared times a to the 3rd, b to the 4th. On these first ones, again, I think in the beginning it's not a bad idea. Excuse me. These are not like attached to each other. Kind of like we were talking about here. When I have x to the 3rd, y to the 4th, there's really a multiplying sign that I'm not writing. Okay? Same thing here. A to the 3rd, b squared. Those are not like attached to each other. All right? So when I multiply these together, I can kind of group my like bases, and I can add just the exponents. 3 plus 3. And then I can grab my b's, and I can add those exponents for those like bases. 2 plus 4. And so this would become a to the 6, b to the 6 as my final answer. All right. If there is no base, like next we have n cubed times m squared n. When we write the variables, we always want them to go in alphabetical order. So I'd grab my m first, but if there is no other m's, this m squared just goes by itself. Then with the n's, I'm going to go ahead and add those exponents. Remember, if there is no exponent, there's really an exponent of 1. So this would become m squared n to the 4th. Okay? If I can show work tonight here, boys and girls, you can show work. Just keep that in mind. Okay? Show us what you're doing in your head. Same on number 12 now. Usually the kids in class just attack this one on their own. When you do that, almost somebody always is going to give me 81. But remember, negative 9 is a base. So the base stays the same. And I'm going to add exponents. 2 plus 3 becomes negative 9 to the 5th. Here's something I forgot to talk about. I say here to leave your answers in exponential form. Okay? Watch out for that. That tells me when I have something like 4 to the 5th or negative 9 to the 5th, I don't have to multiply that out. I want to leave my answer in exponential form. Up here we said to evaluate or simplify. Okay? And so if we say evaluate or simplify altogether, you're going to want to multiply out like we did up here. But on these big ones, a lot of times we'll say just leave your answer in exponential form so that you don't have to multiply out. All right. Last one here for these set of problems. X to the 1/2 times x to the 3/2. So again, the base is going to stay the same. And I need to add exponents. Now this is probably also another good time to write stuff down, because now we're going to review our fraction rules a little bit. These are fractions, so yes, ooh, a little scary. However, it's not that big of a deal. Okay? When you add fractions, just keep in mind you have to have a common denominator. Yay! In this case, we already have a common denominator of 2. And so when you add fractions, the denominator stays the same, and I just add the tops. 1 plus 3 gives me 4. And then now 4 divided by 2, hey, I can do that. 4 divided by 2 is 2. So I just get x squared. Okay, moving on. Okay, now we're going to continue our multiplying, but now you can see, instead of just having a base and an exponent, we also have coefficients in front. Okay? So, when you multiply coefficients, you just multiply those like normal. 8 times 4 is 32. m to the 6 times m squared. Sorry, all that just disappeared on me, but I think we're back. 8 times 4, the coefficients are 32. M to the 6 times m squared. Again, those bases now, m's are the bases, so the base is going to stay the same, and we're just going to add the exponents. All right? Because we're getting a little better with this, I'm going to stop with my adding, and as we get further along with things, I think in the beginning it's good to show our work, but we're going to allow you to kind of come back off that a little bit. All right, so now the next one, 15. 2/3 x to the 4th times 3/4 x to the 5th. Again, I'm going to multiply coefficients, so I'm going to multiply the fractions. When I multiply fractions, I multiply across the top. 2 times 3 is 6. 3 times 4 is 12. When I multiply bases, the base stays the same, and I add exponents. So x to the 9th. You always want to reduce your fractions, so I would say that this is going to be 1/2 x to the 9th. Perfect. Number 16, multiplying. This is where, again, we start to get confused a little bit and mixed up. But keep in mind here on 16, 8 squared and 8 to the 7th. 8 are now bases. They are not coefficients because they have the little exponent on them. So because they're bases, bases always stay the same, and I add exponents. And that's why you got to really pay attention. Am I dealing with a base, or am I dealing with a coefficient? That's why I'm kind of trying to stress this vocabulary. If we have a name for something, think about what it is, use that name, and it'll help you to not, use the wrong rules. All right? Moving on to number 17 now. Multiply coefficients. 4 times -2 are my coefficients. So you get -8. I'm going to add exponents. In this case, because they are fractions, I think I will write this one out so I can think about it. Again, whenever you're unsure, it's always good to write stuff down. If you're going to have to do a lot of thinking, write it down. Show what you're doing. That way if you mess it up. And again, if you write it down, you're less likely to mess it up in the first place. So now I can see, hey, I've got common denominators. So this is going to be m to the 6/3, and 6/3 is 2. So I get -8 m squared. That wasn't so bad. See? Fractions aren't that scary. All right, moving on now. Number 18. When we multiply these, watch out. Again, we start to tend to think, again, like the 8 is attached to the m. The 4 is attached to the m. This negative is attached to the b. And that is not true. Okay? This, again, is really like a -1b and a -1a. If I want to, again, if we don't have a number, we always can go put those little ones right there. All right? And here we are not adding and subtracting, so I'm not going to distribute. Sometimes you guys think we're going to distribute here. This is just like the problems above. I need to start by multiplying my coefficients. I'm going to multiply -1 times -1. I can separate those things. Then I've got to grab my bases in alphabetical order. So I'm going to grab my A's. Then I'm going to grab my B's. Because there's a B to the 1 and B to the 1, I want to add those exponents. So I'd really get here, -1 times -1 is 1. A to the 3rd, B squared. Or just A to the 3rd, B squared. Okay, so be careful if you're dealing with coefficients. They're not attached to things. You can separate stuff. So again, if I get a bunch of stuff together, this makes it kind of nice. I could go, hey, -4 times 3, because those are the coefficients. And really times 1 if I wanted to, because there's a coefficient of 1 in front of the j. Then I'm going to grab my variables in alphabetical order. J, 2 plus 1, since we're going to add those exponents. And then there's just 1k to the 3rd, so we're going to do that. And so now I get -12, j to the 3rd, k to the 3rd. Okay, people always make fun of the way I write my j's. Sorry, that's the way I do it. If you deal with each piece separately, though, I think this becomes a tackleable problem. Sorry, boys and girls, I was running out of time, so I wanted to quickly show my work here. I grabbed my coefficients. -2 times -1 times -5 is going to give me -10. Then I grabbed the a's and added the exponents, so a squared. Grab the b's and the exponents, b to the 4th, and c was all by itself. So there's my answer. Okay, and our last one here, just scooped around to the bottom. Keep in mind, again, these are bases here, not coefficients, so don't multiply the 2's. I want to multiply the coefficients, -1 and 1. The base stays the same. I'm going to add those exponents, and we end up with -1 times 2 to the 8th, or -2 to the 8th. All right, thanks, boys and girls. Have a great day.